Example 3, air propagation. Suppose x represents the measured value of something and x plus delta x represents the exact measurement. Then delta x is the error in measurement. If the measured value of x is used to compute another value, f of x, then the difference between f of x plus delta x and f of x is propagated error. So let's look at a square. And let's say I measured the size or one side of the square to be 3 feet. But the exact measurement, which is x plus delta x, is the exact measurement. And let's say that's actually 3.1 feet. Okay, where delta x, that's the error in the measurement. So that you can see that the error here, I was off 0.1 feet. And then it says to measure the propagated air. Okay, so let's say we're trying to find the area of the square. That would be f of x equals x squared, and f of x plus delta x equals x plus delta x squared. So the propagated air is going to be the difference between the actual area and the area that I found based upon my original measurement that was 0.1 feet off. So we could do that really easily, and that's known as delta y. So we could do 3.1 squared minus, well, I guess I'll write this just so you get used to what the formula is. This would be f of x plus delta x minus f of x, where x plus delta x, that's going to be 3.1, and f of x is going to be f of 3, where f of 3.1 would be 3.1 squared minus 3 squared. And so let's see, 3.1 squared is going to be 9.61 minus 9, which would be 0.61. And this would be feet squared. That would be the propagated air. Okay? Another way to figure this out, and this is the way that we're going to use for the problem that we do here in a moment, since we know that delta y is equal to f of x plus delta x minus f of x. We also know that the derivative of y is equal to f prime of x dx. We also know that delta y is approximately equal to dy. especially as the smaller dx is. So how we're going to find these problems here, how we're going to find the propagated air, we're going to take the derivative of f of x, which would be 2x, and then delta x for this problem would be the difference here. So this is going to be 0.1. And then we know that x was 3. So let's see, we would get 6 times 0.1, which is 0.6, which is really close to what we got, which was 0.61. So this is the estimation of air, or the estimation of the propagated air. Let's try one with this example down here. In the figure, a radius of a ball bearing is 0.7 inches. So we know the radius is 0.7 inches as shown in the figure. The measurement is correct within 0.01 inches. So that would be the delta x. Estimate the propagated air in volume of a ball bearing. So first of all, we're going to let x equal the radius. We're going to let delta x equal plus or minus 0.01 because it's correct within 0.01, so it could be greater than whatever the radius is or less than. We know that the volume of a sphere, which would be the bearing here, which would be 4/3 pi r, which is x cubed. Okay, we'll just call this f of x. Okay, and they want us to estimate. So we're estimating the propagated air. When we're estimating the propagated air, we're going to use f prime of x, or I'm sorry, we're going to use dy equals f prime of x dx. So dy is equal to, take the derivative of this is going to be 4 pi x squared, and then dx is plus or minus 0.01. The measure of x is 0.7. Okay, I'm going to stop this video and finish this up on the next one. No, I can keep going. I got time on here. Sorry. So then, let's see here. dy would be four pi 0.49 plus or minus 0.01. So then dy would be 4 pi times plus or minus 0.0049. And then dy would be plus or minus 0.0049. I'm sorry. 0.0196 pi. So that would be the propagated air. This is volume. So this would be inches cubed. That's how much the air would be. Okay. Now let's talk about calculating the percentage of air. To calculate the percentage of air, you're going to it's going to be dV, which is the volume, which we just called dy, over y, where this would be y. So this 4/3 pi x cubed, that's the actual air, or that's the volume based on the air. And then let's see, if we use this guy, that's my dy. So 4 pi x squared plus or minus 0.01 all over this, which is 4/3 pi x cubed. So we can simplify this a little bit. The 4's cancel out, the pi's cancel out, and you can reduce these x's. So you're going to have plus or minus 0.01 all over 1/3 x, where x is 0.7. Yeah. And you could multiply the top and the bottom by 3, so plus or minus 0.03 all over 0.7. So this is going to be plus or minus 0.042857. If we wanted to actually figure out the percentage, then you multiply this by 100, move it over 2 places, so this is going to be 4.2857%, plus or minus. So that's how much it's off, percentage-wise.